Example problem 4 reads, a 30-liter sample of nitrogen inside a rigid metal container at 20 degrees Celsius is placed inside of an oven whose temperature is 50 degrees Celsius. The pressure inside of the container at 20 degrees Celsius was 3 atm. What is the pressure inside of the nitrogen after its temperature is increased to 50 degrees Celsius? So there's a change in conditions happening here. Temperature is being increased. So we know we're using P1 V1 over T1 equals P2 V2 over T2. So reading this again to see exactly what is happening. There's a container of nitrogen and it's being placed inside of an oven. So before the nitrogen is placed inside of the oven, the nitrogen's temperature was 20 degrees Celsius. And then it heated up, which caused the pressure to change inside of the nitrogen container. So the pressure inside of the container at 20 degrees Celsius was 3 atm. So we're going to have a P1 and a T1 that's relevant. The first pressure was 3 atm. The first temperature was 20 degrees Celsius. So that means we're going to have a P2 and a T2, and that we're going to be looking for one of these things. What is the pressure? So we're going to be looking for a P2 of the nitrogen after the temperature is increased to 50 degrees Celsius is going to be our T2. So they do tell you that the volume was 30 liters, but that's completely irrelevant at this point. Because all we need to solve for this is the pressure and the temperature. So we can go ahead and get rid of volume because we're not being asked for volume. It doesn't tell us that the volume changed. At this point, we know that the pressure and that the temperature changed. So what we have here is P1 over T1 equals P2 over T2, which is called Gay-Lussac's law. So we can go ahead and convert our temperatures because we know that they are not in the correct units. So for T1, it's going to be 20 degrees Celsius plus 273.15. So 20 plus 273.15, and that's going to equal 293.15 Kelvin. For the second temperature, it's going to be 50 degrees Celsius plus 273.15, and so 50 plus 273.15 is 323.15 Kelvin. So now we're ready to put this into our formula. So P1 is in 3 atm, and atm is the correct units that I want y'all to use for this. T1 is 293.15 Kelvin equals P2 is X, or you can call it P2 if you want to, that's fine, divided by T2, which is 323.15 Kelvin. So last time I worked it where we handled the fraction and then we handled the other side after that. This time I'm going to go ahead and cross multiply to show y'all how to do that in case you haven't had that in algebra yet. So multiplying these two, it's going to turn into 293.15 Kelvin times X equals, and then crossing these two. So in your calculator, 3 times 323.15, that's going to equal 969.45 atm kelvins, because neither of those units went anywhere. They didn't cancel. So then at this point, to isolate X, you would divide by 293.15 Kelvin, and that will cancel, divided by 293.15 Kelvin. And so here you can see where Kelvin cancels and you're left in atm, which is appropriate for pressure. So in your calculator, 969.45 divided by 293.15 is going to be a P2 of 3.30, so we'll say 3.31 atm. So let me know if you have any questions about example problem 4.